Hi everyone, we are back today and we are going to be making our Nylon 610 using 1,6-hexane diamine and suboxyl chloride. So if you've ever done this for my UOP students, if you've done this kind of chemistry before, this nylon rope polymerization, so we're polymer experts. But as I've said in this class many a times, we are not chemists. We're only polymer chemists. So I'm going to show you the one polymer chemistry that I can do, which is nylon interface polymerization. Specifically, it's going to be a step growth reaction as opposed to a chain growth reaction. So we're not going to have any chain propagation. We're going to have step growth. So we are going to do our nylon 610 interface polymerization. We are going to mix, again, our diamine, 1,6-hexane diamine. So again, these amine groups, H2N, so CH2,6. So that's going to be one of our kind of one of our kind of steps in our reaction. Remember, we have our generic A plus B plus C. Actually, I'm here, I'm going to write that down right now live for you. So we have our general reaction of A for chemistry. B plus B yields. So our reagents yield some product. This plus harder than it looks. We're drawing right at this sleep time. So that's our generic, kind of, again, or any reaction. You could write a K equilibrium. We've done that and we've seen that kind of in our notes. And hopefully you've done that previously. So we are going to mix first our hexane diamine into our solution. We are going to add that with suboxyl chloride right here. And we're going to produce our byproduct, which is going to be HCl. Don't worry too much about that acid. It's not going to be produced too much. But here we're going to produce our nylon 610. So now why in the world do we call this, sorry for the shaking, nylon 610? Well, we're counting the number of, in these kind of really distinct, there's kind of these two repeat units, or depending on how you break this up, or structural units. Here we can see that there are how many carbons? 6 carbons. What about in this group here? Well, there's 8 right here, and then 1, 2, 10. So this is nylon 610. That's it. You're a polymer expert at this point. Now, the reason why I mentioned before, if you've ever done nylon polymerization, so for my UOP students, if you've done it in Chem 24, I don't know if they do that or still do that, but when I was at MIT, whenever we did this, it was horrible. It never worked. You could never pull the nylon, it would break. The reaction was super slow, very sensitive. Now, why is that? I think I figured it out. I'm not a polymer chemist expert, but I am a Mech 202 or polymer physicist, and I know one thing. I know that for my reaction to proceed, to produce as much of this as possible, to produce as much of D as possible, I need my K equilibrium to be as high as possible, right? Because our K equilibrium, in our most generic terms, is going to be our products, C. This was, again, an interview question at Intel. I aced that question, but I still got the job opportunity. I should have taken it, but instead, that's a story for another time. But anyways, this is my K equilibrium constant. So if I want to produce as much of this as possible, D, my nylon 610, I need my K equilibrium to be very high. 10 to the 4th would be ideal. And how do I get a high K equilibrium? Well, I know from my nucleoacyl substitution, you've hopefully watched that video, that this is very electronegative, chlorine. This is also electronegative. So it's pulling away the electrons here. It really wants to interact with this one right here. We know that this leaving group, or this kind of group right here, has a very high K equilibrium, 10 to the 4th. Now, I bet you, and if I actually do have my notes, one day I'm going to find my notes from my nylon polymerization, I bet you that you've done polymerization using a group like this group. I'm going to hide it right here. COOH. What do we know about that K equilibrium from our notes? Very, very low. So our K equilibrium there is low. That's why that interface polymerization, that nylon synthesis route, doesn't work well. So let's see if I'm going to jinx myself and completely fail today, but I'm pretty confident from my basics and my kind of the understanding and the fundamentals that we do here in this class that we're going to be proven right. So I will see you all in the next video, and let's see, or not the next video, but in the second part of this, and let's see if this works. Hopefully I don't make a fool of myself. It's been known to happen before though, so no worries. All right, I'll see you all in the next video. Back All right, everyone, we are back and we are going to start and create our nylon synthesis. So I have my graduated beakers here. I'm working in secondary containment, if you can see. I also have my kind of bottles here, right in here and here. Gloves on, of course. I can put these in a secondary containment, but I'll mix it over here. And yeah, I have also the glass rod, which we will utilize to kind of roll our nylon rope, and my nifty basically hook to grab that first strand. If you look here, there's corrosion. Again, that's due to that acid, that's that byproduct, that HCl. So first I'm going to mix my hexane diamine, and then I'm going to mix my subacyl chloride here into the solution. So I will show you how to do that in a second. Note the light's on in our hood. You can also put the blower on, but it's the loudest blower I've ever heard. It needs to really be fixed. Something is wrong mechanically. Lots of vibrations. Ask your Professor Lee if you can, she can help you with that. So I'm going to go ahead and start to mix this, and I will see you in the next iteration once we do this transition. All right, thanks. Bye. So let's mix hexane diamine first. So I want to pour this slowly and on the edge here. So just pour it slowly in. I want to get around 25 milliliters right there. Close enough. All right, next one's coming. So now I'm going to pour in up to 50 my basically subacyl chloride right here. So I'm going to do this very carefully. You can see that kind of steam, and you're going to see this interface basically appear here. Glad I'm doing this on 50. And you can see that interface right there. It's hard to kind of see in the video. Again, this is why it's nicer in person. But you can see this interface starting to form. So that's our nylon. So now's our chance. So let's go ahead and let's grab this rope. So here, I'm going to stick my cube in. And you can see I've got my nylon here. And I need to quickly stick it on here, sorry. I have to close the video for a second. All right, we are back, sorry. So look at, I'm pulling my nylon. I'm just wrapping it all around here. So look at, you see? Now the key thing is not to touch the side, so I've got it, but you know, the only chemistry I know is this nylon polymerization, so I'm an expert in this only. So, you see it's just coming, and I'm going to pull out the whole solution. So get ready to be bored. This is where, unfortunately, again, if we were in person, we could kind of chat. You could tell me where your favorite, what's your favorite TV shows to watch. But isn't this exciting? Again, I mean, we're going to pull out this entire solution. There's not going to be any byproducts left. And this is much better, again, than what I've experienced previously from when I did this as a student. So I figured out the key, and the key is subacyl chloride. But I'm just going to keep winding this until my solution disappears. So this is the beauty, again, it's so unfortunate that we can't be in person to kind of do this together, but this is, you know, polymer chemistry and chemistry in general is kind of very, can get abstract. So learning, and that kind of goes to any discipline. And that's why labs are so important. And again, unfortunately, that's why labs hand-on experience are so important. Not to say that you're not going to gain a lot from this remote experience, but seeing this in person and kind of, you know, figuring out or, you know, being able to kind of tangibly see chemistry happening is very invaluable. So, and this is super fun too. I don't know if you're as enthralled, but the first time I did this when I was asked to teach a polymer course at Pacific, I knew I had, you know, polymer chemistry. People really didn't actually. The previous course did not cover it, or covered it a little bit, but I knew that the best demo would be this, and the only demo again that I could use. I know one other chemistry, and it's biotin streptavidin in my research, but that is much. Although you could kind of show that pretty cool with my rolling magnetic particles, but. I love this polymerization, and it's so cool to see that, again, we've talked a lot about the K-equilibrium constant, right, for our leaving groups, but seeing that in action, and actually seeing the difference from when I was a student, this never worked. You can never, you know, oh, did I touch the side? No. you could never in a million years hope to kind of grab as much of the polymer as I'm grabbing right now. But lo and behold, we're doing it. That's it. All right, I broke it, but it's good. I think people got the point. So this is really kind of expanded. I'm going to take it to the sink. And you could kind of, if you touch this, and you could feel there's some hydrogen, you know, see there's some kind of leaking. That's kind of the byproduct here. So I'm going to wash. This is very, very, you know, again, low concentrations. You can worry. You don't have to worry about kind of washing the sink. So I just want to squeeze this guy, wash it off. Squeeze, squeeze, squeeze. And I'm going to go ahead and just take off now at this point. We'll clean up. I'm not going to show you the cleanup for the rest of it, but I think you got the point. There you go. That's nylon. So I'm going to put it here, let it dry. But what you'll end up with is something, let's see where to put it, like this. From all my other demos, this is nylon. Again, nylon that's in your clothes, nylon that's it's nylon 610, your first polymer chemistry. So congratulations, and yeah, we can't do that in person, but again, if you want to do this demo and kind of see this live, I usually, again, once everything hopefully is back to normal, I usually do these demos for Tiger Days and for parent weekends. So, or you could just kind of drop by the office, come to office hours, and we could do this ourselves if you're really into it. So I will see you all in the next video. Thanks. Bye.